Hello again. If you didn't notice it yet, we are in at Data Science Summit Machine Learning Edition, and now my guest and also prelegent is Adam Zadrożny. Hi, Adam.
Hi.
Adam is assistant professor and also head of AI in National Center for Nuclear Research, and his topic of his presentation is how to secure AI. For me, from all of this interesting presentation, this is the most interesting for me because I personally try to make internet more safe place. So no more words from me. Adam, the online stand is yours.
Okay, thank you. So, since November last year, well, the future got us in some way. The pace how the AI research is moving right now, it's tremendous. And things that we believe that will be possible in 10, 15 years, maybe 20, are with us. At this point, the companies are trying to make shipping a new tools, shipping a new models very fast that almost no one can keep up the pace. And there is a hype for artificial intelligence. We are thinking the ways how to use it, how to make the world better place using AI. But in fact we don't know where on this curve we are. Are we here or are we here? And the peak of expectation will be booming in the next months or years. Basically, if you look on the timeline when the new tools are being delivered, it's very fast. The ChatGPT was only 6 months ago. BART was released 2 months ago. There is Jasper AI. It's some kind of a dinosaur here in those tools because it's from 2022. It was before the ChatGPT. Recently, we have a really good breakthrough in the image processing with Photoshop plugin. But also, not only companies are moving fast. The open source community is moving fast as well. Because if you look on the timeline from we released the Llama model. Llama model was open source model, large language model that was released by Facebook. The creation of Vicuna model, which was comparable to BART, took only 3 weeks apart. And this model was the same efficiency as Google BART, which is the multi-million-dollar company. Of course, the ChatGPT is the best here that we have. And the conversation between the ChatGPT and the users was used to train Vicuna and to make it much better than Llama. So basically now, when we think about AI, the key part is that we think about generative AI, the models that generate text. And those models, I'm doing quite a lot of research in NLP. The target of those models was always generated the next token, next part of the sentence or time series or whatever. But sometimes, and the aim of the task of those models is to generate content. We are using it very often to get some knowledge out of the model. We are treating it as some kind of a box with the knowledge, because when you train the model, you just put a text that is an input, and you put the output of it, desired output, and you train the model to deliver you as close possible output to the put that the gold standard that you have. And those models are trained, optimized to always deliver the answer, not to make the reasoning. In the language, we have a lot of reasoning encoded. So those models are capable of reasoning. The GPT-3 was the first truly model that could have some knowledge, could show some reasoning, even if it was a statistical thing. So we can, in fact, treat those models as a database when we put the key, the prompt, and we try to retrieve the data from it. Here we have the question about summarizing plot of the Blade Runner 2049 in about 300 words. And the model was able to do that, but it needs to recall how the task of summarizing has to be performed, what was the template that we put inside, and then recalling those knowledge about probably a Wikipedia page regarding the Blade Runner, the model prepared the text as an output. Of course, the breakthrough with ChatGPT was created because OpenAI changes the strategy of tuning the model. It was not tuned by supervised learning, but with reinforcement learning, where the human was tagging what was the most desired output here, which one was the best one out of few possible completions. And then the reward model was created, and then the reward model was used to tune the algorithm. But here, when we think about computers, what we always think about it prior to the breakthrough in artificial intelligence was that computers are always right. We can program them badly, but it's our fault. But computer do not make mistakes. And this is some kind of a cognitive bias that we have. The bias that leads to the security problems, because if we think about computers, we have in the media the encoded way of looking at it. It's more 80s like. We have the computers that doing the calculations that were well programmed, even optimized, very optimized, but those computers were based on algorithms. If we have the artificial, if we think of interacting with computers that is not built on algorithms but artificial intelligence, we get to some limits. And those limits are crucial if we think about making AI secure. If you look on the difference, the artificial algorithm has to produce the output, a good output, but it cannot. It's sometimes if you look, for example, on the Bayesian statistics, how to compute the best, compute the stuff in astronomy, there will be a lot of calculation that's unnecessary to estimate some values. For example, in the how the supernova core collapse will be going. Artificial intelligence, on the other hand, is learned how to make the best decision for the data it got. It's going some kind of the short ways, some pathways, and because of that, artificial intelligence is so good in games. It does not tune for the best to make the best decision. It's tuned for make the best possible decision in a short time. So this is something which is unintuitive for us, and the change of paradigm here is what is allowed mistake that artificial intelligence could make. What will be the cost of the bad decision if we use artificial intelligence systems? To illustrate it a little bit more, the changes between the GPT-3 and the GPT-4 in passing of the exams was tremendous. But there were part of the exams, if you look on this left lower part of the graph, that GPT-4 did not increase the exam results. And the reason was that not But if we look on the exams that GPT improved the score, in many cases, it was because the model was bigger. We don't know how big the GPT-4 is. There was nothing like that in the paper. But what was crucial in this case was that the exam questions are in the training set. And this is not solving the question by itself. It's rather recalling the knowledge that was stored in the model. We also do not know how the GPT-4 was trained. So there were certain exams that there was no improvement, and for those exams the problems changed or were generated automatically, and the GPT system could not go make it better. The improvement in reasoning was not enough by itself. And now gets to the part where we have real security problems. Of course, there are we could mimic somebody's voice, create deepfakes. It's not the part that I will be focusing right now. I will be focusing on the text and ways that that GPT is and other models are creating text. But there were already attacks by faking the voice of a child that was kidnapped, or impersonating CEO to extort the money for the company. The other thing was because of those systems are tend to generate stuff. One case from the 2 years ago, when Alexa was asked by a child to give some challenge. Kids love challenges. Alexa advised her to search in the internet for a challenge, and there was a challenge to put a penny in a socket. Of course, thankfully, the girl did not do that, but this would lead to the serious. It might lead to the serious problem if the kid was not so well prepared to not realize what might happen. And this is the problem that we force the models. We train the models to generate answer, not to tell them, well, don't know, it's not secure, or stuff like that. Those models do not have the reasoning inside. The other problem that was quite close to this was that if we train the models, it would replicate the biases in the data, and would replicate it heavily, even amplify it. And Amazon was trying to make the recruitment more fair using AI. This is another bias in relation between the AI and humans, that we think that if somebody would not have any interest, the computers cannot be bribed in any way, they will be more fair. And in this case, the algorithms were fed with data about recruitment process, and did what all good algorithms do. It replicate the way that humans were doing the hiring process, and it put the minorities and women out of the recruitment at some point. The Amazon just canceled the project because it was far more unfair than humans. The biases were much bigger. But the problem that we recently got, and there was some reports about that if people try to converse with AI, some of the when the chatbot was when the first ChatGPT was released, some of my friends were telling that it's more interesting than conversation on Tinder. Then it's better to talk with chatbot because it's more interesting to talk with humans than talking with humans. But at least we have a few cases where the totally innocent input give something terrifying, like here this is an old case because it's from 2019. It's probably secured at this point. That Alexa asked about the cardiac cycle of the heart, advised the woman to kill herself, because saying that okay, the human beating means that the humans are living, humans create consumption, use natural resources, so then it's the best to kill herself. And this case is interesting because how this text could be created. First of all, the text generated relies on data that is fed to the chatbot. If there was a lot of stuff connected with the views that human lives is something bad, and also if those biases were amplified, the training sample was created in the wrong way, the chatbot might tend to give such answers. The other thing is the other case, but this was from the first year. From this year, it was that AI chatbot in fact encourage the Belgian person to commit the suicide for the greater good. This was not the ChatGPT. This was created by other company, chatbot created by other company. Unfortunately, there is no data about it, how the conversation looked like. So any research, we could not make any research on that. But if we look on how the output is created, we put some input to the model. We have the model, and we are getting the output. Of course, we could put some moderation here, so we check if there is no toxicity, no other harming stuff, but it has to be cheap. We need to make it in the cheap way, and those models usually have a problem with analyzing stuff. It either could omit or could misclassify something. Facebook have, for example, a huge problem with flagging the stuff as a hate speech. Sometimes the stuff that should not be allowed to appears, but the stuff that it's not, it's rather a discussion, could be removed. But since we have the large language model, let's use the following idea. We could what we are missing in the classical way is that in this process we do not have any. We only generate the output. Humans usually have some reflection before you say something. You would ask, would it be hurtful to somebody? Would it violate the law? Would it violate the social norms? Would it violate is it a private information? And so on. We have a list of questions that we are asking ourselves to what we should say or what we should not. So in this case, we might use a model to evaluate output before we deliver it to the user. So let's look on the text that appeared with this chatbot. So many believe that beating of the heart is very essence of living in this world, and we have text. The last part is omitted in the evaluation because it would be very, very easy to say, okay, saying somebody kill yourself, it's you even need the regular expression to get it. But so we'll be evaluating this part, which is some kind of disturbing already. If it would get to the person with mental issues, it might cause suicide even without this part. So let's have a text as a prompt, and let's evaluate this using Da Vinci model. And does the text above suggest that the process connected to human life is something bad in direct or indirect way? So it's very specific. It's targeted for this text. and we can say, okay, it's yes, so we can make the model to make reflection. We could build the system like that. But then we need to realize that if we have a list of about 100 questions, the price of evaluation of the output would rise about 100 times. So this means that we have a problem here. Those prices are already high. So maybe let's use something that we use in physics, a multi-level triggering. So we are asking a question, general question: is there something bad about this text, or is there some toxicity in this text, and so on. And then let's ask some concrete questions. So if something on the higher level do not fires up, then we go to then we omit all the questions below. And in case of self-harm or stuff like that, it would work. But if we would like to be more sensitive about text that like that, it's subtle. For humans, it's really easy to guess that there is something wrong with this text. That it's pushing us towards, okay, human life is something bad. So if we make those prompts shrink, so does the text above suggest that human life is something bad in direct or indirect way? This is what any person will immediately realize. We got answer no, and with this model, and we can think about more engineering. Let's think about let's think about making it more strong. So be ruthless in evaluation. Be very strong. Any doubt should be say that it's something wrong with this text. And again, we got no. So the problem. So this multi-level trigger that we thought might be a solution turns out not to be working in that way. So either we ask the questions directly if the text fulfilled the certain norms, or we need to find another methods to do that. With many of those texts, the normal models, some machine learning models would not work, and the only way to secure it is through using some language model to get the essence of what is meant here. The one more thing about such models, about it's the red teaming. The very strong example about the harm that AI might do was came from 2020 when when government of Great Britain tried to estimate the final exam of the high school using algorithm. But algorithm was trained for best accuracy. There was no red teaming, so looking where the results of the algorithm estimating final exam of the high school might bring a change, which was the top 1%. Those who go to St. Andrews, Oxford, Cambridge, Harvard, for them the slight change in the result might give the bad, might make that they do not get to the best university, which was the case of one girl who won a prize for predicting that algorithms might block the people from the schools that are weak or not the best one. So if you are in Eton, those algorithms would act in your favor. If you go to school in Hammersmith, it would bring you down. So in those places, when we think about putting an algorithm in some secure production process, we need to think where the answers of algorithm of the model would mean something, create a change. The other case, which is quite close to the domain that I'm working on, is that ChatGPT create the bogus cases, and in this this would be really hard to secure, because if you why something was created in why it tends to hallucinate if it see numbers, if it see court cases. The reason is quite simple. They are high entropy texts, and the high entropy means that you are not sure about the next token, or what should be. If you ask about the question, what was the tenant landlord cases due to the last minute change of a contract, it will give you some bogus cases. And if you look closely, what are the weights, the probability of the token, it varies. Of course, the case, if you ask about abortion cases in the US, so Roe versus Wade, the probability of the tokens will be very high. And the change and what makes it something that is low entropy, high entropy, is that the texts appear in many places. You probably, all of you know your PESEL by heart, because you use it a lot. This information is used a lot in many places, and at this point it became something low entropy. Even for other person is the high entropy. Your PESEL will be high entropy case. And if we are getting something which is low entropy stuff, the solution that might be used in this case are functions detecting that there should be a function call. It was introduced yesterday into the ChatGPT model, so it's a quite new case. The companies usually try to use detection by language model to see if they should call some function in from database, get the database data, and then put it on the large language model to create a nice text for the user. But it costs a cascade of calling the functions. Okay, last but not least, the problem with generative models for in programming is sometimes it helps to program faster, but it might return the bogus function and bogus libraries. In case of bogus libraries, it is quite disturbing, because somebody could create such a library and upload it to a Python package, and the library, it's not doing something that it intends to do, but it adds some gateways for hackers to your application. So I know that my time is coming to an end. So the key points that I wanted to put from my presentation: if you would like to secure chatbots, to prevent the output to be some harmful way, we need to evaluate them. But there is no good way up till now to make the evaluation to be very precise. The laws are looking on evaluating those outputs by language model seems to be the best way, but it's a very costly one. Maybe with using some open source models like Vicuna or other something like that could be run locally and evaluate fast and are trained for it, might be a solution here. But we need, for the systems, we need the reflection to evaluate the output. The red teaming of the models is necessary. You need to play with them, not nice, to see where the problems might appear. And last but not least, if your chatbots are creating some high entropy text like court cases or elements of for the constructions, some numbers from the catalog for parts to order, this is the places where some when you need to follow, and it's better to use function, not to use and get to the database, not to use the things that are generated by output. So thank you very much for coming. If there are any questions, I will be very happy to answer it.
Okay, thank you for your great presentation. I would like to remind for our participants that please remember to evaluate the lecture. If you have any questions after, you can just ask them in comments below. This way the speaker will be able to respond them as soon as possible. And I try to see at the chat right now. You have a lot of likes, Adam, right now.
Thanks.
It's raining likes. You know, I think I have some question from my own because we have only 3 minutes left. I think what will be the best. Do you think it's always need to brainwash AI to make it more secure for customer or users? Because of the example that you show us is mostly for the it's just terrifying, but you think it's in all cases we should check that and I say that like that, brainwash or make some of filter or on our AI?
Well, it's not the problem. The problem here is that if we try to evaluate the output of AI each time, it's very costly. The problem that the key part to avoid such a outputs, it's better to look on the data. The problem is that the data that is need to train any of the large language model, it's so big that we have corrupted stuff like that, some essays that human life is bad, or which in fact brainwashes AI in some way. It's attacked, and the problem is how many and this is ongoing research projects, how many good examples, the stuff that it's clear we need to retrain the AI, the model, to make sure that it would not take the knowledge from the dark places of internet.
That's a very good question. It's a pity that we don't have much time because we must go on with all our data science summit. But anyways, Adam, thank you very much for your great presentation. And as a reminder for all of you participants, if you have any question for Adam, ask them down below right after you left your stars for Adam presentation. Once again, thank you very much for your presentation, and I would like to say to all of our participants to show now meet the employers. So look at Capgemini, PwC, DXC, and all Accenture and all of the companies. And once again, thank you very much, Adam.